Right, today in Algebra 2, we're going to look at section 11.4, the first day of it. So our essential question, how can you use the normal distribution to explain where data values fall within a population? And after today, you should be able to understand where a data value falls in relation to other values in a normal distribution. So we're going to start out. There are certain sets of data where the data when graphed are symmetrical with a single peak, central peak at the mean of the data. The shape of the curve is described as bell-shaped, with the graph falling off evenly on either side of the mean. 50% of the distribution lies to the left of the mean, and 50% of the distribution lies to the right of the mean. Such graphs are called normal curves, referred to as normal distributions. The mean, median, and mode are all the same in a normal distribution. So here's an example of what a normal distribution or a bell curve looks like. Properties of a normal distribution. Number one, a normal distribution is curve-shaped and bell-shaped. The mean, median, and mode are all equal and are located at the center of the distribution. A normal distribution curve is unimodal, which means it only has one mode. The curve is symmetric about the mean, which is equivalent to saying that its shape is the same on both sides of a vertical line passing through the center. The curve is continuous, which means that you can draw this without lifting up your pencil. The curve will never touch the x-axis. The total area under the normal distribution curve is equal to 1 if we are talking about probability, or 100% if we're talking about percents. 68% of the area is within 1 standard deviation of the mean. About 95% of the area is within 2 standard deviations of the mean, and about 99% of the area is within 3 standard deviations of the mean. You need to know those. 68%, 95%, and 99%. You need to know those. Okay. All right. The normal distribution has a special property called the empirical rule. So this is what the empirical rule looks like, and this is what I was telling you, that this is your 68% within 1 standard deviation above or below. Within 2 standard deviations above or below the mean is 95%. Within 3 standard deviations above or below is within 99.7 or 99%, we call it. Okay. The standard deviation, okay, and its notation is the Greek letter sigma, determines how much the data are spread out. The smaller the standard deviation, the more concentrated the data and the narrower the graph. The larger the standard deviation, the more dispersed the data and the wider the graph. The standard deviation can be used to subdivide the space or the area under a normal curve, starting from the mean. Each of these subdivided sections can be used to represent a portion or percentage of the data falling into these sections of the graph. The normal curve shows how likely it is to find a value within a specific distance from the mean. So if we look at this, this is going to be our average, okay? So this is your average here. Sorry, this is our average. And this is within 1 standard deviation above. So this is our average plus 1 standard deviation. This is our average plus 2 standard deviations, and then our average plus 3 standard deviations. Out here on the ends, these are called the wings of the graph. So then I have another wing out here. And then going the opposite direction, your average, okay, or your mean minus 1 standard deviation, your mean minus 2 standard deviations, and your mean minus 3 standard deviations. We need to know the percentages, and we need to memorize these percentages, okay? So the first two, within 1 standard deviation above or below the mean, is 68%. That's because each portion is 34%. So this is a 34 and this is a 34. Our next sections are 13.5. Our next one are 2.35, and our wings out here at 0.15. Same going this direction. And again, you need to memorize these numbers. So you need to memorize 34, 13.5, 2.35, 2.35 was right there, and then the 0.15 out at the wing. All right, so let's look at some examples. An example of an early application of statistics was in the year 1817. A study of, chest circumference among a group of Scottish men exhibited an approximately normal distribution. Their chest circumferences ranged from 33 to 48 inches, with a mean chest circumference of 40. So they're telling me my mean is 40 and a standard deviation of 2, right? So my mean is 40, my standard deviation is 2 inches. Use the empirical rule to help you understand the distribution of chest circumferences. So the very first thing we're going to do is draw our bell curve. I drew the first one for you here. I have it provided. It's right in the center. That is going to be our mean, 40. My standard deviation is 2, so I go, sorry, go back to that. It was moving. I'm going to add 2 to that. So 40 plus 2 gives me 42 is my next section. Add 2 again, I get 44. Add 2 again, I get 46. I go back to my mean, and I want to subtract 2 each time. So this gets me 38, 36, and 34. Remember that this is 34% of my data, 34%. This is 13.5. This is 2.35, and my wing is at 0.15. Same this way. These numbers will always be the same, and we're memorizing those. All right, so part A, what range of chest measurements contains the 68% which fall closest to the mean? Remember, we also said that 68% was within 1 standard deviation above or below the mean, okay? So, and if you notice, 34 plus 34 gets us 68, so this is our 68%. So that's between 38 and 42. So between 38 and 42 inches contains 68%. Part B, what would you expect the chest measurements to be for the 2.5% of the men with the smallest chest measurements in the population? So the smallest, if I take 0.15 my wing plus 2.35, that gets me 2.5. So anytime they're asking you for 2.5%, I'm looking at the wing and the very last section. So the last 2 areas. So I see that is between 34 and 36. So we would say less than 36 inches. Because everything less than 36 inches is going to fall in between that 2.5%. The next one, what would you expect to be the smallest and largest chest measurements in the middle 95% of the mean? Okay, so we'll go ahead and write smallest and largest, and then we'll go back and we'll look. Remember where we said, I just passed it right here, 95%, okay, that is within 2 standard deviations above or below. So in this case, this is my 95%. So my smallest would be at 36, and my largest would be at 44. So our smallest would be 36 inches, and our largest would be 44 inches. And then the last one says, what would you expect to be the measurements of the 16% of the men with the largest chest in the population? The 16%, okay, our largest. So we're going to start at the end, 0.15 plus the 2.35 plus 13.5. Those 3 numbers will always add up to get you the 16%. So those 3 areas will always be 16%. So if I look at our graph, these last 3 areas here are what we're looking at. So that would have to be greater than 42 inches. So what would I expect it to be? Greater than 42 inches. Right, so now let's try some more of these. So number 2 says, recent SAT scores for college-bound seniors are normally distributed with a mean score of 508 and a standard deviation of 121. How does the empirical rule help you understand the performance of individual students? So first, we need to draw this. So I'm going to draw my number line here. Ooh, that was not very nice. So straight line. And then we want to draw a bell curve. In the center is where my mean, my average goes, 508. I need to go 3 above and 3 below. I add my standard deviation of 121 each time. So 508 plus 121 gives me 629. 629 plus 121 puts me at 750. 750 plus 121 puts me at 871. I go back to 508 and I subtract 121 and I get 387. Subtract 121 again, 266, and subtract it again, 145. Remember, this was our mean. If it helps, go ahead. I know that this is 34, this is 34%. You can go ahead and just draw out my, so this is my 13.5, 2.35, and my 0.15. 13.5, 2.35, and my 0.15 out of my wings. All right, so part A, what proportion of students receive scores between 387 and 629? 387 and 629, that is within one standard deviation. So we have either memorized that that is the 68%, or if you haven't memorized it, it's 34 plus 34. Okay. B, what proportion of students receive scores greater than 387? So greater than 387, I take all of those and I add up, okay? Or I know that from the mean, the 508, everything bigger is 50%. So I could just say 50 plus this one little area 34. So that is going to give me 84% of the students received scores greater than 387. C, what proportion of students earned SAT scores between 266 and 750? Again, between 266 and 750. So that's within 2 standard deviations. So hopefully we memorize that, 95%. Or I would just have to add up all of those. So I would add up the 13.5 plus 34 plus 34 plus 13.5. And then finally, what proportion of students earned SAT scores between 266 and 629? So 266 and 629. I'm going to add those up. So I've got the 34, 34, so 68 plus 13.5, which gets us 81.5%. All right, so now we're going to try again. Given quiz scores of 30, 50, 60, 70, 90, draw a normal curve. I'm going to draw my bell-shaped curve. Draw a normal curve if the standard deviation is 20. This time they didn't tell me what the mean was, but we know how to find that, right? So our mean, remember we add up all of our numbers and divide by how many we have. So if we add 30 plus 50 plus 60 plus 70 plus 90, we get 300. There are 5 numbers, so divide by 5 and we get 60. So our mean is 60. Go 3 above, 3 below. We're adding 20 each time, so 80, 100, 120. 40, 20, and 10. Again, if it helps, go ahead and mark this. So I know this is 34, 34, 13.5, 13.5, 2.35, and then 0.15 at the wings. A, what percent of the scores are above 60%? Well, that's half of them, so that's 50%. Right? What percent of the scores are below 40%? Okay, so I can add those up. So that's going to be my 13.5 plus 2.35 plus 0.15, which is always going to add up to equal 16%. What percent of the scores are between 40 and 80? So between 40 and 80, again, that's my empirical rule, that's 68%. B, if 50 students took this quiz, how many scored less than 40%? Well, we know that less than 40 40 was 16%. So basically we're asking, what is 16% of 50? So 0.16 times 50 means 8. So 8 students scored less than 40 if 50 students total took that test. Let's do a few more of these together. Number 4, the amount of time a trainer spends with a young elephant in any given week is normally distributed. If the trainer spends on average 12 hours per week, okay, so we're going to go ahead. Our curve. So my average is 12 with a standard deviation of 3. So I'm going to add 3 each time. So 15, 18, 21. And then I'm going to subtract 3. So 9, 6, and 3. There's my middle. Again. So I know these were 34 and 34. And so on and so on. It says, what is the probability? Okay, so this time we're seeing the word probability. Probability means no percent. Okay, so therefore it's a decimal. What is the probability that the trainer spends between 12 and 15 hours a week with the elephant? Between 12 and 15, that is 34%, but as a probability, 0.34. If they ask you for percent, you're dealing with up to 100%. If they're asking you for probability, then you're looking at numbers between 0 and 1, so with a decimal. They ask you for the proportion, you're still looking at the percents. Number 5, the blood cholesterol readings for a group of women are normally distributed with a mean of 172. So I'm going to draw my curve. So 172 is my average. I need to go up 3 and down 3. Standard deviation of 14. So we're going to add 14 each time. So I get 186, 200, and 214. I get 158, 144, and 130. And again, if that helps you, go ahead and do your divisions here. I know 34 and 34. Right, so now we're going to use that to answer these questions about what percent of women have readings between 158 and 186. Again, those are within 1 standard deviation above or below, so that's always 68%. B, readings less than 158 are considered desirable. About what percent of the readings are desirable? Again, that's from here down. We have that memorized as 16%, or until you get that memorized, you just add up those areas, 13.5 plus 2.35 plus 0.15. What is the probability that a woman has a reading of 200 or higher? 200 or higher, so that's my last 2 areas. So I'm looking at 2.35 plus 1.5, right? And it said probability. So remember, probability, I don't want a percent, so this is 2.5%, therefore 0.25. 0.025. Sorry, wrote that wrong. 0.025 for 2.5%. All right, so that is our very first day of looking at normal distributions and bell curves. Tomorrow we will continue with this, okay? Only we will learn about what's called a z-score. Your homework over this will be a worksheet. So the 11.4 worksheet number 1, where you will have to draw your own bell curves, create all of your divisions, and answer questions based off of those.